Hi, Pradyumna. Welcome to the podcast Everyday Metallurgy.
Hi, Peter. Thanks a lot for inviting me over to your podcast. I see you are a family of metallurgists. That is, I think, it is not very common,
No, it's not.
and it gives me pleasure. It just reminds me of my old days at when I was doing PhD, and
Mm,
where I used to see metallurgy folks every day doing something or other, uh, and
mm,
making samples, preparing samples, looking at microstructure, looking at metallographic
yeah.
structure, and doing experiments.
Mm,
So just amazing. So I think your question was what brought me here.
mm,
You
yeah.
said that you wanted to your what was your question, Peter?
Yeah, I would like to give an introduction to the theme today because over the last month I have had several people requesting what is going on with this AI and machine learning in the world of material development. Will it change anything, or are we still stuck in the old way of developing? Uh, because we know when we look back, when stainless steel was developed, it took a couple of years to develop the first real industrial alloy. Is that still the speed we develop new materials at, or will AI change? And therefore, I reached out to you
Hmm.
because you are one of the pioneers in the world of combining AI and materials development, and I would love to learn from one of the experts.
Sure, thank you.
Yeah, can you give a short introduction to your own background?
So thanks a lot, Peter. Yeah, certainly. I think before speaking about AI and materials, I'm very passionate about material science. I think materials science is the kind of invisible engine behind every technological leap that we see. It is right now there are a lot. AI is one of them, but
Mm,
behind AI is basically semiconductor or photonics or batteries, aerospace, quantum materials.
mm,
All this field is there. As my background, I'm a PhD in material science. Very passionate about my PhD was on photonics, and I will
mhm.
talk about it
Yeah.
later. I run a company called Infinita Lab. It's a big platform where we have 2,000 plus labs in US and
Mm,
400 plus in Europe. See, these are our network labs, and we do. This is the world largest material testing network. So we do testing from, you know, metal, plastic, semiconductor,
mm,
fabric,
yeah.
toys, everything you can imagine. And
Mm,
that naturally also includes quantum materials, so very highly, technologically advanced materials,
mm,
batteries, EVs, and all other fields. Um, I think the movement today is very, very different. And I love that you have a very good topic. So, this is my short background, and
mm,
I just want to talk about uh, your topic.
mm,
If you the question you asked about what is going to happen in AI,
yeah.
what is different, anyone would answer that. That's an easy to answer question. You know, AI is affecting other fields. The easy thing to think is that, okay, hey, it was slow earlier, AI is making everything fast. Yes,
Mm,
it is making things fast
yeah.
for material science. So that's easy answer
Mm,
to do. Um, but why it is fast? There are two reasons. It is that AI is assisting material science, but material science is assisting AI too. It is tied. This loop
Hmm.
is tied.
Yeah.
This is not a single that AI is actually
Hmm.
leading to material discovery. So if you would have asked 10 years back, if you would have gone with a new material to, let's say, iPhone manufacturer, Apple,
Yeah.
and you would have said that, okay, hey, this material would actually make your chip faster, right? Compute
Hmm.
faster, would have more memory and everything. They would have said, okay, come tomorrow.
Yeah.
The reason is that they don't need more computing power 10 years
Hmm.
back,
Hmm.
right? They did not need more computing power or memory or something. Whatever they had, that incremental change was good enough.
Hmm.
Now AI came, and Apple is struggling currently as we speak to actually put AI in their phones
Hmm.
because they cannot do 3D packaging. The whole thing is heat up.
Yeah.
With AI, what is happening is that in the semiconductor, I don't know whether your readers would be familiar with it, so I will just give a primer.
Yeah.
In AI, the you basically need a lot of data to be processed parallelly, like at the same time.
Hmm.
So it is like you have a road which is 6 lanes, right? So you
Hmm.
can have maximum six cars go
Yeah.
straight, right?
Hmm.
Side by side, right? It was
Yeah.
fine
Hmm.
because up to now it was fine because everything was serial. So six car will go, then six car will go, and then there was a line of this,
Yeah.
you know,
Hmm.
2000 cars that were one after other, right? But
Hmm.
now all these 2000 cars need to go all at once.
Yeah. A big road.
So now, you need sort of different kind of architecture that you stack up basically road over road over road over road.
Yeah.
And it is not available yet. When you stack up, basically it heats up
Hmm.
the material. So
Yeah.
basically that's the problem that AI is facing, and that's why there is a materials problem
Hmm.
here, fundamental material architectural problem. How to process huge amount of data all at once. That has caused a crazy rush to find new materials,
Hmm.
a pull
Yeah.
to find new material or new technique. So, so that has happened, and because of that, material science is just exploding, and photonics is coming in. If you know how the copper wire was changed to optical fiber,
Yeah.
and the reason was copper fiber, copper was conducting electrons.
Hmm.
Electrons are heavy. You need a
Yeah.
lot of energy to move them from one place to another.
Hmm.
And then, but in the case of photons, you don't need that much energy. So the
Hmm.
loss is not there, heat is not there. Okay.
Yeah.
So it was replaced by photonics. So
Hmm.
same thing is gonna happen in AI eventually, because in photonics, in photons, you can carry a lot of data,
Yeah.
and but it doesn't have any weight.
Hmm.
So it doesn't generate heat. So
Yeah.
that would eventually happen in the case of computer hardware as well, which will be able to be very high bandwidth, carry AI
Hmm.
signals from one place to another place. So
Yeah.
yeah, process huge
Hmm.
amount of data.
Yeah.
So what I'm trying to say is this in a nutshell, roaming around a lot of places, but in a nutshell, what I'm trying to say is this. AI is helping AI material science, but material science is also helping AI, and you have not seen
Hmm.
up to now what really the true potential of AI is um, on your devices or smaller devices.
Yeah.
That would probably come in few years.
Yeah. So then it will really boost if we can succeed and develop instead of having copper lanes to conduct, having photon driven, you can stack and
So,
make it a lot more dense. We're not talking nanometers wide, bandwidth. We are talking photon tubes or
hmm.
well, how? Because when you conduct photons, you need it into a tube where it cannot get
Optical,
out.
optical. So it
Yeah.
will be basically photonics. It will be just like electronic parallel in photon is photonics, where basically you basically not conduct is not the right word they use,
No.
but it is like lasers, a lot of like
Yeah.
optical signals go
Hmm.
around,
Yeah.
and you control them, you multiply them, or you
Mm.
reduce them in number, or you stop them, just
Mm.
like the computer does with the electrons.
Yeah.
And so that is, some part of the electronics.
Mm.
If you look at the chips from NVIDIA, there are companies like Celestial AI that are working on photonics part, integrating photonics in the electronics. So some part of the electronics is already being changed
Yeah.
to photonics because there is no alternative. It is
Mm.
it is the one which will generate less heat. So the
Yeah.
future, uh, so what I'm trying to say is that demand is right now on materials to step up and
Mm.
give the AI what it wants, higher
Yeah.
bandwidth and everything.
Yeah.
It is not available by the traditional
Mm.
materials. And that's why there is a lot of demand and pull for new materials that were solved. Like, somebody new
Mm.
invention were there. Photonics
Yeah.
is known for 30 years. I did my
Hmm.
PhD on photonics.
Yeah.
But, there was no excitement, no pull, no demand.
Mm. No. So it the step to take, or is that the intermediate step until we reach superconducting materials?
Superconductivity are totally uh,
Mm.
different types of materials. So you were talking about, also AI assisting materials discovery,
Yeah.
right?
Mm.
So there are obviously, it was the easy answer that okay, yes, it is going to happen, and it is happening.
Yeah.
But just if I go a little bit deeper and talk very high level, easy to
Mm.
understand terms.
Mm.
It took like it used to take like new alloy development is like 10 to 30 years
Mm.
because basically you are going empirically, you are adding one element, few elements,
Mm. Yeah.
running a statistical model if you
Hmm.
are sophisticated a little bit, and then basically running these trial, melting it, testing it,
Mm.
failing it, then repeating this whole process, right?
Yeah.
And kind of making phase diagrams and all these,
Mm.
fancy things in order to
Yeah.
kind of create where we are.
Mm.
Uh, so that part, if you look at all this thing, the number of things are being taken over by AI.
Mm.
Okay. So what I say is this, if you think about it a little bit high level, anything that can be put on paper or computer, that could be done by AI right now.
Yeah.
You cannot
Mm.
use robots are not good enough that you can melt it or make many composition. I mean, although that has
Mm.
also been done in Berkeley, UC Berkeley, they have
Yeah.
a robot. It's called Materials Genome Project or something, which is running for
Okay.
last 10 years,
Yeah.
where They have they find out using machine learning, they found out that okay, these are the 10 composition or 100 composition that should be made,
Mm.
that are good enough, and then the robot comes in and then it makes it,
Yeah.
and then looks at whether the predicted properties were the same as the
Mm.
properties that they find
Yeah.
eventually.
Mm.
But it's still, I feel that that part of melting, testing, the physical part is still there, but anything that could
Yeah.
be put on paper or put
Mm.
on computer or
Yeah.
done through computer,
Mm.
that all would be done by AI much better.
Hmm.
So I tell you about literature survey. You start with a literature survey.
Yeah.
Done.
It's done in seconds
It's
today.
done in second. And I mean, when I used to do PhD days literature survey, it was only English
Hmm.
journal. What about Spanish? What about Chinese?
Yeah.
What about Korean? What about
Mm.
uh, Japanese, right?
Yeah.
They are much more advanced in
Mm.
this. There are no Russian, right? So
Yeah.
I would just take all of these. The AI can do that.
Mm.
What about patents as well?
Yeah.
So I will not do patent search basically.
Mm.
So that could also be done.
Yeah.
So that literature survey is gone.
Mm.
It very smartly it will do it, and you can do much better in that.
Mm. Yeah.
You can create your experimental plan much better. So you can reduce your, first of all, finding the gap is better. So
Mm.
whatever the research gap is there, you can find it,
Yeah.
right? And then you can kind of reduce the number of sort of combination to a certain level,
Hmm.
right? And then
Yeah.
the physical part which comes, then basically, our uses.
Mm.
You can have, so, you can test out lot more at the end of
Mm.
the day,
Yeah.
but you still have to test. But
Mm.
that basically accelerate the
Yeah.
pace of things much faster.
Mm.
And then when you have the robot, then you just sit and
Mm.
explain that, okay, hey, this is your PhD topic, and then it will be done.
Yeah. 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 I have some. Maybe it's not that easy because a lot of materials, if you melt them and you have melt metallurgy, the properties of the material is here. But if you make them powder metallurgy wise, you have different properties. If you heat treat them, you might reach a material that is not in equilibrium, but you freeze it kinetically out of equilibrium. So therefore, it might be difficult to foresee the properties of materials with databases. So do you also see that as an obstacle for developing it using AI, that you need a lot more physical testing to find these specific properties, not only as function of material blend, but also as function on how you process them?
Yeah, certainly. I think if you look at the space, right, it is one dimension.
Hmm.
Processing is one dimension.
Yeah,
You're talking about, um, cooling it very fast. Let's
hmm.
say metallic glasses,
Yeah,
right?
exactly.
Where you have uh, very thin ribbon of things
Yeah.
that you can create, or
Hmm.
you are, spray drying, like spray deposition, right?
Yeah.
Where you are
Hmm.
cooling very fast and then
Yeah. Hmm.
depositing on a platen. So all
Hmm.
these kind of processing also another dimension. And for AI, it is again one dimension, right?
Yeah.
I think, you know, I might be wrong, but there was a study, even very smart human being, right? They can think mostly in two dimension. This is why we have graphs, right?
Yeah.
Plots,
Yeah.
X, Y.
Yeah.
And when it goes to three dimension, we are like, and then after that, we just give up,
Yeah.
right?
Yeah.
So now that is where AI comes in. and it can also think about this multi-dimension spaces. Your phase diagram also is a kind of you know you know just a few dimensions, right?
Yes.
Pressure, temperature, you
Mm.
know, right?
Yeah.
So my thing is, I mean, now we are talking about multi-dimension, and
Mm-hmm.
that is very exciting.
Yeah.
So AI basically, what if you think about it, it actually collapses the combinatorial explosion of compositions, if you can think about it.
Mm-hmm.
There will be you can think of somebody will come up with this at the end of the day, if you're talking about composition, and actually whenever I talk to material scientists, they basically just go into compositions.
Mm.
That is the wet dream of a metallurgist. That
Yeah.
okay, hey, how can I look at all the combination of all the elements
Mm-hmm.
and basically figure out what I can make or not, right?
Yeah. Yeah.
Now that is basically possible with
Mm.
AI and easily
Mm.
possible. That is the crazy thing. Tool
Yeah.
is available.
Yeah. Uh, but yeah, can we jump deeper into how is it done? Uh, because there's a lot of talking about, yeah, you just have to take AI, you have to take machine learning, and then you put in some wishes, and then there's an output. But I don't believe it's so easy. Can you walk me through how it's done? What is needed of input
Mm.
to start that process?
So I'm not very I'm not very versed in I mean I did not do computational models
Mm.
or machine learning but the the way it is done, either density functional theory or molecular dynamics, you're using some of the first principle physics where you are not even thinking about uh, uh, not even thinking about uh, you're not even taking the literature survey. You're not even thinking about it that, okay, hey, literature survey is there, where basically you just take the atom by atom, and then looking at the physics, if
Mm.
you combine this thing versus that thing. Um, all of this would be basically accelerated. Um, how it is done currently, it has been done basically even before current, using using machine learning. It is
Mm.
not like a new thing that has come up.
Mm.
So like 10 years or even 20 years back, machine learning way is basically that you are combining these things and doing it. What
Yeah.
is different is this: in machine learning or in computational models, um, whatever was being done was being done at a very small level. If you cannot expand it to a bigger level.
Mm.
Now with AI, what will happen or happening is that it is being done at a bigger sort of um, um, bigger atomic set or bigger level, right?
Yeah.
You can include lot more atoms and you can actually run
Mm.
a bigger set in there. It doesn't answer your question how it is done, because I'm
Mm.
not how guy.
Mm.
I am a why guy, and what is being done. So
Yeah.
unfortunately, that question I cannot answer that well.
Mm. That's fair. So if I'm working a lot with magnet materials, and there's a lot of debate these days about rare earth elements that are abundant in China, but all over the world where we use the magnets, We do not have access to the materials. So the moonshot dream is can
Rarer.
we can we use this new mythology to find the recipe for the rare earth-free magnet that has high remanence, high coercivity, high corrosion resistant, everything there. Do you think that would be possible?
Yeah, I think uh, there is high possibility now,
Mm,
right? Um uh, it again I what I so material science is two things.
mm,
Okay, in the case of AI, things that you can do on computer, modeling, you can
mm,
literature survey, analysis of the data,
mm,
and so forth, so on. You can do things that are on the computer. You can think,
mm.
right? But then the second part is basically doing things in the lab, polishing, making, combining,
Yeah.
melting,
Mm,
right? Doing things properly, right?
yeah.
So, and literature survey, the things that you can do on the computer. Let's go on first take this part and then let's say we can do the other part like melting and everything which physically very very
Mm,
good. Okay. This part that you can do on computer also have things that are done in the past and can affect it. For example, literature survey. Literature survey is pulling from a large pool of database,
mm.
right? There's the work done earlier.
Yeah.
Problem with that database is that it is not very clean
Mm,
because the people who publish the papers may have not done their experiment very well. They
uh,
found something,
yeah.
they had a
Mm,
raw material which was contaminated. They found
mm,
something which was,
yeah.
on the edge, right? So for example, I will give you superconductors, right?
Mm,
There was a like 2, 3 years back, there was a Korean lab which came up with a room temperature superconductor.
uh-huh.
And on Twitter, it was a frenzy. So people started saying, oh shit, this, and the common people, common, folks, they were
Mm,
trying to repeat that experiment. None of them could do that.
yeah. Then it's difficult. And yeah, I understand that.
It,
The data is there, but it's contaminated with crap sometimes.
so now that is the problem. So
Mm,
AI can do its part,
yeah.
right? But the high quality magnetic property database
Mm,
is required.
yeah.
Now, accurate crystallographic and electronic structure data is required,
Mm,
right?
yeah.
Accurate. And
Yeah.
I am talking about all these things accurate. Clear
Mm,
performance constraint are required.
mm,
That temperature stability, coercivity, all these things are required.
yeah.
But having said that, AI would just accelerate this part. If you,
Mm,
my point is this, AI is not magic. It cannot do magic
mm,
on something which is very bad. Crap in, crap out. If you
yeah.
have crap
Mm,
in, then you would have crap. You just accelerate the crap to
yeah.
another level.
Mm,
Okay. So if a good data set is there, somebody has good data set, which companies have good data set, by the way. But that is proprietary. That is not available to people. They have tied it down to their server. But
yeah, of
if a
course.
company have a very good data set
Mm,
on magnetic properties and everything, their own, right? Or couple of
mm,
companies, they come together
yeah.
and then they use this clean up the bad data and then
Mm,
take this data set and then feed it to their own LLM, own
mm,
AI program,
yeah.
and then make something out of it. I am pretty sure that something good will come out.
Yeah.
So it is possible right now. Only thing is needed is basically good data sets, good data
Mm,
set,
mm,
and then there is a very high possibility that
yeah. Mm,
that they can actually do the rare earth free magnet, super magnet, or whatever.
yeah.
And I think that would happen. And
Mm,
I tell you why it is going to happen.
mm,
Because if I can think of it, people can think of it.
yeah.
Probably that would happen in China. Because
Mm,
China can force companies to cooperate.
mm,
In US, it is harder. Companies have their databases and
yeah.
good, clean, good, high quality databases that they
Mm,
would actually, or the workforce that can actually do that, but then they will not cooperate.
yeah. And you need to share the data
Yeah.
to have a proper level of input data.
You need good data, run
Mm,
good AI models on those data,
mm,
and then come up with something and then basically make them very controlled conditions.
yeah.
And if that is done properly,
Mm,
the physical world and the computer
mm,
power is there now.
yeah.
The physical world, if it is done properly,
Mm,
it's come together properly, then it is possible, very, very possible.
mm, yeah. So if we look on the broader world of material development and what is needed, what is the urgent, is there a top five of materials that you think will be the first breakthrough that we'll see developed using AI?
What will be the first thing? I don't know what is the first thing, but I think there is a lot of emphasis on batteries right now. So solid
Mm,
state battery, for example,
yeah.
batteries,
Mm,
it's there is a lot of urgency towards solid state battery, cheaper batteries.
yeah.
So so that we can fly in peace.
Yeah. And
We can-
and higher power density of the batteries.
Hmm?
Higher power density.
High power densities.
Yeah.
But I think bigger thing is that battery safety. Right now, battery can go to higher power density and other things, but the safety is a big thing.
Mm,
Then, temperature range they operate at is another thing.
yeah.
And the main key issue is actually not AI related. It is
Mm,
not composition. It is basically uniformity, scaling. In the
okay.
battery, the
Mm,
problem is as much as like solid state is one thing, but I think it is
mm,
about the uniformity that what you have produced in the lab,
mm,
that you can actually scale it in
mm,
production. Problem
yeah.
is that the tolerances are very tiny, very, very tiny.
Mm,
So it's unbelievably tiny.
yeah.
So the battery production right now is very sensitive. Now,
Mm,
whether you answer it with some sort of testing or you answer it with some sort of composition which can have a higher tolerances and still the properties do not fluctuate,
yeah.
that's another issue. But I
Mm,
think solid state batteries, electrolytes, I think are going to be a good search. I don't know whether AI can actually help there. And not I don't know. I know that AI would actually help there.
mm, yeah.
Second, I think obviously you said about magnets.
Mm,
Then are high entropy alloys for extreme environments.
yeah. Yeah.
So
Yeah. So high temperature,
you're talking
high
about
strength. Yeah.
space applications,
Mm,
right? You're throwing a rocket, it is going somewhere and this that,
yeah.
right? Um, Carbon capture materials. You can,
Hmm.
I feel that that is where a lot of research is going. Carbon capture, you know,
Mm,
basically you can control the atmosphere if you think about it.
yeah. Mm,
Currently, that is, you can control it is more important than you can reduce. Control is the importance, right?
Mm. Yeah.
If you look at your all the big cities, they are dirty.
Hmm.
All the big cities in the world,
Yeah.
they're pretty polluted
Hmm.
because you cannot control the air.
Hmm.
So people don't think about it because it is good enough and
Yeah.
we can survive.
Mm.
And but it is very important. And then high temperature superconductors.
Yeah.
That these are all $1 trillion questions.
Yeah. Yeah. Absolutely. Uh, and maybe materials that can enable fusion energy.
Fusion, yeah. I mean, there are a lot of normally, yeah, energy generation basically what you're talking
Mm.
about.
Yeah.
Yeah.
Mm.
So, but that is more of a system level thing. Um, that is not a material science challenge only.
Mm.
That's a system. Fusion is a like they are fusing hydrogen, right? So
Yeah.
superconductor, for example, would actually help with the fusion. So if
Yeah.
you
Absolutely.
so
Mm.
basically if you think about materials that would enable it, that is basically
Mm.
superconductor.
Yeah. Yeah. To run the big magnets to make the field, so you don't need the liquid helium and all the risk about it.
If you think about materials, I would say, I mean, even then it is with Infinita Lab, I come across a lot of companies, basically
Mm.
the companies that are at cutting edge. They require Infinita Lab services. They require a lot of testing,
Mm.
right? So I get exposed to a lot of different kind of companies. And so when I was things like uh, nuclear reactors that are very safe and
Mhm.
like neighborhood level.
Mm.
So if you think about like all the energy comes to us from sun,
Yeah.
very fundamental level if you think about it.
Mm.
We are made of sun, right? We are
Yes.
ener so we eat trees or animal
Hmm.
trees,
Yeah.
plant life, and
Mm.
plant basically are nothing but they capture the carbon
Yeah.
and then they have water and nutrients from the earth, right?
Mm.
So
Yeah.
basically they are nothing but air, right?
Mm.
Sun and earth, and then from there we are formed,
Yeah.
right? So all this is and other source of energy is basically nuclear. If you think
Mhm.
about it, like just
Yeah.
these two things are sun and nuclear, and even
Mm.
sun has nuclear energy in it,
It
right?
is. Yeah.
So the nuclear is basically what is a big thing.
Mm.
If it will be, in my opinion, it is quite important source of energy in places where there is less sun.
Mm.
Okay, or if you are
Yeah.
going to another planet, nuclear
Yeah.
is very important.
Mm.
So, in my opinion,
Yeah. Yeah. So small modular nuclear plants that are flexible, removable,
yeah,
will
Uh,
be a part of it.
yeah, 1,000 to 10,000 homes. Uh,
Yeah. Mm. Yeah. Uh, but now, if we look ahead, all these things has been solved. The lanes with the cars stacking is fixed. We have the photon computers. Will that be in 10 years from now, or will it be further ahead? What is timescale of these things, do you think?
so, looking at if I look at one layer down, and I
Mm.
said that okay, hey, materials specifically, if I talk about materials specifically, there are two parts of the puzzle. one part of the puzzle is solved. AI algorithm and whatever you can do on your computer is done in seconds now,
Mm.
right?
Yeah.
Rather than years,
Mm-hmm.
right? So that
Yeah.
part is solved, but it's still the part about making it, melting it, you
Mm.
know,
Yeah.
really testing it, right?
Yeah.
All that part is still physical.
Mm.
So, the speed is halved, you can say.
Mm.
You know,
Yeah. Mm.
if I talk very roughly, it
Mm.
used to take, let's say, 5 years for a PhD, in which the person will spend 2.5 years doing computer work.
Yeah.
Now that computer work is down, gone.
Mm-hmm. Yeah.
So, but it's still that half of it is still there, right?
Mm. Yeah.
So
Yeah.
that's the thing.
Mm. Yeah. So if I translate that to the steel world, in theory, the computer can make a phase diagram of steel, and in the phase diagram you have iron, you have cementite, and that's it. And the iron can be ferrite and austenitic. But then when we make the experimental work,
Hmm.
we find structures that we name binite that has some properties. We find structure we call martensite. Martensite doesn't exist in the phase diagram.
Hmm.
So all these experiments expand our learning, and we need to put that experience into the system.
Hmm.
And then the system can continue building on these shoulders. Is that also what you foresee now? If we don't look at steel any longer, if we look to next generation material, there will be the new martensite that doesn't exist. It will appear, and then we will teach the AI about that.
So I'm just thinking
Yeah.
AI is a more intelligent system that can work day and night.
Mm,
You can tell, we can tell it stories about a lot of things. We can say that, okay, just like now you said that a martensite doesn't exist in the phase diagram, right?
mm,
And we can tell it that, okay, hey, it doesn't exist. It will know like we know,
mhm.
right?
Yeah.
So,
Yeah.
and it will consider it,
Mhm.
like we consider it.
Yeah.
Uh, and as you said, that it can actually take it and consider it and build a system and maybe predict something. So that prediction part, which
Mm,
we were doing ourselves,
mm,
would become easier, you know.
yeah. Mm,
Even if it is not, since we have shown it the microstructure, we have
mm,
shown it what mortisite look like, why it makes it the steel harder, right?
mm, yeah.
It is a dimension of processing, basically. We cool it very fast, right? That's
Mm,
why martensite appears, right?
yeah.
And it is so we can tell it. We can also tell that, okay, hey, microstructure wise, why it happens, what happens, and it will
Mm,
also consider it.
yeah.
You know, maybe it will find the logic about it. I
Mm,
don't know.
yeah. And then be able to transfer that to a new system that might react the same way. So it might be able to foresee the martensite, the fantasia structure of the new alloy system that we have never seen before.
Possible. So
Yeah.
what I'm saying, and more, because it will just open up dimensions it will open up possibilities basically.
Mm.
And that is my expectation is. It's a good question. It's just forcing me to think that it will
That's a big question.
basically it will actually open up. in my opinion, it will just open up a space of possibilities.
mm,
And the reason why is you know, computer were dumb in the sense that they were defined by our own intelligence, right? Or systems,
mm,
when we if we can think on two dimension maximum, we can force the computer to think, like up to now, the system to think in three dimension,
mm,
because we had some idea about three dimension. So we said,
yeah,
okay, hey, let's force it, it will come up with something.
mm,
Now we have truly a system that is like a kid growing up, and it can do things that initially, yes, we have given it something
mm,
to think about, but it can actually, after a certain time, it can actually go on its own
yeah,
development. Like,
mm,
it can actually prune itself, it can make itself better, right? And it is
yeah,
not limited by life's processes, that okay, hey, you are a 40-year-old now, so now your metabolism would be slow and everything.
yeah,
It is not limited
mm,
by that.
mm,
So now this system, like as I said, the Chat GPT 4 point, no, Chat GPT 5.3 that was released on February 5th,
mm,
it has a line there, the codex lines there, that now this system it built itself. They have
yeah,
it has built itself.
mm,
Now that is big statement, a scary statement,
mhm,
because it has improved itself. Same thing can happen in the case of phase diagram and others. If we give it
mhm,
input, it can actually go in the direction
mm,
of sort of improving itself and thinking in other dimension too. It says that, okay, hey, I see this processing dimension too, which was not considered,
mm,
and why not I just go and explore that,
yeah,
and it will do it.
yeah,
But if so, it is just limited now by its own thinking.
mm. Yeah, I can see big potential, but it's also a bit scary that
It is scary. It is.
n- i- and it has already happened that it can build itself. So it will also happen in material science that it will develop materials that we never even imagined we could ask for.
Peter, philosophically, our kids are better version of ourselves.
Yeah.
Maybe AI is a kid,
Mhm.
is a much better version of ourselves.
Yeah. Yeah.
So,
Let's
that
hope for
is
that. Mm.
that's is the kid scary? If your kid is very smart,
Mm.
I think that
Yeah.
is the question we should answer.
Yeah.
If the kid, I think it is, I think scariness comes because the the moral values
Mm.
may not be the one, AI may not have any morals.
Yeah. I see. Um, so my last question is building on this. Where are we in 10 years? Will there still be need of people like me, or will the system has taken over?
So see, I'm in Silicon Valley. I always feel very optimistic. For
Yeah.
me, glass is always half full,
Mm.
you know. So, and there is a lot of space over that. I feel, the Stadia is similar to what when computers came, people said that, okay, hey, all my jobs will go away.
Mm.
And they did. They
Yeah.
did.
But new appeared.
but there is no limit new appeared
Yeah.
because you know why?
Mm.
Because there is no limit of human imagination or human want.
Mm.
So, you will go to Mars, possible, but
Yeah.
then as soon as you will end up on Mars,
Mm.
a human being would say that, okay, hey, I want to go to another solar system.
Yeah.
I want to fly by for fun. I want to fly
Mm.
by Pluto. I want to
Yeah.
see with my
Mm.
own eyes how it feels.
Mm.
At this stage, I just want to see. I mean, personally, if you want, I would like to go and see Earth from outer space.
Yeah.
I want to, I want to see from, like, just like astronauts see. No
Hmm.
matter. So what I see is this. I feel that there will be more because human ambition
Mm.
has no limit. So, material science question, I feel that there is a lot to be done.
Mm.
AI would not be in the physical spaces anytime soon.
Mm.
So, but since it is on the computer space, on the virtual space, it can actually accelerate things. And I think 20-year thing would be in 5 to 7 years time,
Yeah.
even with in material science. So,
Mm.
because they're limited by the physical space right now.
Mm.
So, things that you develop in 10 years, maybe 3 years, 4 years, you would be done.
Yeah.
And and yeah, and that will accelerate.
Mm.
And the nature of AI, just because the nature of AI is that it is now building itself, it will be more things that you think were not possible, it will actually start doing that
Yeah.
soon.
Yeah. Yeah.
It is
Yeah.
only limited by, it is right now only limited by what it can think
Mm.
is possible. Because as soon as it will think that, okay, maybe we should go into this other dimension, just like we were talking about, as
Yeah.
soon as AI would think that, it will go and do it.
Yeah.
So it is just limited by what it can think. It will
Hmm.
just blossom into that area, blossom into that area.
Mm. Yeah. Thank you. Uh, if people want to learn more about this subject, do you have two recommendations where they should go? Uh, is it conferences? Is it papers? Is it a YouTube channel?
I mean, certainly they should read my LinkedIn post
Yeah.
where you actually we connected.
Yeah, that
But
was
yeah,
how I met you.
but I think MIT, Stanford,
Mm.
CMU materials, AI research, they have a AI research group on materials.
Mm.
So they should just look at that. Um, UC Berkeley has this material genome project
Mm.
that they should look at. There is a AI summit, I think AI summit coming. So if there is a lot of AI interest, I
Yeah.
think, but the issue is that AI is a different kind of AI in materials is different
Yeah.
kind of thing than AI itself.
Yeah.
In
I agree.
AI conferences, they don't talk about materials yet,
Mm.
which is I don't know why it is because materials are what is stopping it right now. But there is a lot of talk now in
Mm.
materials world about AI, so
Yeah.
that's a good thing.
Yeah.
Citrination, I don't know whether you know citrination.
Mm.
It's a if you they Google it, citrination, Citrination, citrination.
Mm.
So citrination is a good you know, citrin. I think is the one which is now in the case of citrination. It is basically on chemical compound and materials breakthrough, and they are, I think, using the AI quite a bit.
Okay.
It is Citrin Virtual Lab. It's a company now, Citrin.io.
Hmm.
Yeah.
Yeah. Fantastic. Thank you very much. Uh, I learned a lot. I reflected a lot of what you said. Got a lot of inspiration and a little scary, but I hope our mutual child is a good child that behaves well.
Yeah, no need to be scared. I think actually it is not about being scared or not. I think it is
Mm,
scary that people are worried about uh, and worried about what is coming. And
mm,
the scary part comes because even if you look at the all the AI top guys on AI who have
mm,
created AI, what is happening is that AI is being developed by a very small group of people, very small group of people
mm,
who are kind of at the forefront and actually controlling it. Few companies are controlling it.
mm.
And even those people who are at the center of it, they don't know what is coming.
Yeah.
And that uncertainty makes them worried and everyone else worried.
Mm,
So it is worrisome stuff, but also exciting. I say it is more thrilling than exciting for material science because a part of the puzzle in material science, which is physical space, uh, is not taken care of.
yeah. Mm, yeah.
All right.
So let's end on that note. Thank you very much for joining in and sharing your knowledge. I uh, I feel a lot wiser now.
Yeah, me too. Thanks a lot, Peter. Appreciate
Yeah.
for great questions and forcing me to think. Thank you. Have a
Thank
good
you.
one. Bye bye.